Okay. This Zoom session is being brought to you by the one-point fractal picture of itself. All right, today we're going to be doing solving 3x3 linear systems, 3 equations and 3 unknowns. And of course, ax by plus cz equals I, dx plus ey plus fz equals j, ex plus gy plus hz equals k. Given the capital letters a through k are constants, find the variables x, y, and z. Now, we'll rescale and combine, just like with 2x2 systems, to eliminate variables. Now, because this is 3x3, there's like 12 numbers involved, as opposed to 2x2, which is 6 numbers, half as many. So this is a longer, more difficult problem set, and that's just the unfortunate all there is to it. So I'm going to go to relatively fewer problems just to show how this works. Here we go. X plus 2y minus z equals 5. 2x minus 4y plus z equals 0, and 3x plus 2y plus 2z equals 3. We'll do much the same thing. I'll pivot on an entry to clear out its column, like here, by row operations and combining operations mostly, in order to eliminate variables. So for example, here's an x, here's a 2x, we subtract twice equation 1 from equation 2. Here's a 3x, so we subtract 3 times equation 1 from equation 3. All right, and so let's see. 2 minus 2 times 1 is 0. So this is a 0. 3 minus 3 times 1 is a 0. So this is a 0. Here we have a 4. 4 minus 2 times 2 is a negative 8. So we put a negative 8 here. 2 minus 3 times 2 is a negative 4. So we put a negative 4 here. 1 minus 2 times negative 1 is a 3. So we put a, a 3 here, and let's see, and 2 minus 3 times negative 1 is a 5, so we put a 5 here, and 0 minus 2 times 5 is a negative 10, 0 minus 2 times 5 is a negative 10, we put a negative here, 3 minus 3 times 5 is a negative 12, which we put here. All right, now, okay, here we have this system. We've cleared away x from all this. That's good. Now here I have a minus 4y and a minus 8y. Okay, I'm going to subtract equation 2 from equation 3. 4 minus negative 8 is a 4. 5 minus 3 is a 2. 12 minus negative 10 is a negative 2. That makes things a little bit simpler, I guess. There we go. Okay, copying that from before. Oh, wait. Oh, I see. I think the advantage was is that, let me look back of the page. 4, 2, and minus 2. Divide this, we scale it by 2, and we'll get a 1z here. That's why I did that. I have this 5, and I decided to make it into a 2. And these are all even, so we can divide by 2, and we get the simplest system with a 1z here. Serrolano, admit. Did I already let you in? Never mind. Okay. Anyway, 2y minus z equals negative 1. So we can use this z to clear away this 3 here and this minus z here. We add all the one of equation 3 to equation 1. X remains x. 2y plus 2y is 4y. Minus z plus z is a 0. And 5 plus negative 1 is a 4. Here we'll subtract 3 of equation 3 to eliminate this 3z here. Minus 8 minus 3 times 2 is a minus 14. Minus 10 minus 3 times negative 1 is a negative 7. Okay, great. Now we've eliminated all the variables from this second equation. Minus 14y equals negative 7, all but y. So we divide by negative 14, so you get y equals a half. And then simple, since we have a y here, we'll subtract 4 of equation 2 from equation 1 to eliminate this 4y. Subtract 2 of equation 2 from equation 3 and let's eliminate this 2y, and which is basically the same as a substitution. And we get x equals 2, y is a half, z equals minus 2. And there you have it. There's the solution. It is the same as a 2x2 system, but yeah, it's basically twice as many steps. And that's annoying. And that's all there is to it. I'm sorry. Here we have a system. 2x plus 3 equals 1, 3 minus 2z equals 6, and x minus 2y equals -9. Well, this is a lot more blanks in it, which makes it faster. We have an x here and a 2x here, so we'll subtract twice equation 3 from equation 2. 2 minus 2 times 1 is a 0. There it goes. 0 minus 2 times -2 is a 4. We have a 4y here. 1 minus twice 0 is a 1, so we have a z here. 1 minus twice -9 is a 19, so we have a 19 here. 4y plus z equals 19, and the rest of the system is as before. Okay, here. I get in this case, I decided to turn this 4y into a 3y by subtracting equation 2. 4 minus 3 is a 1, 1y, z minus 2z is a 3, -2z is a 3z, 19 minus 6 is a 13. So this first equation becomes y plus 3z equals 13. Now we can use this pivot on this y to eliminate this 3y here by subtracting 3 of equation 1 from equation 2. And we can eliminate this minus 2y from by adding twice equation 1 to equation 3. And after the usual additions and combinations as noted here, we get that this equation becomes minus 11z equals -33, and this one becomes x plus 6z equals 17. Okay, we've eliminated all the variables except z from the second equation. We'll rescale, divide by -11, and we'll get z equals 3. All right, z equals 3. We'll eliminate the 3z from the first equation by subtracting 3 of equation 2 from equation 1. And here was 6z in equation 3, so we subtract 6 of equation 2 from equation 3. And after appropriate combinations noted here, we get y is 4, z is 3, x is -1. But of course, we want to swap them around to put them in alphabetical order. And here's the solution. X is -1, y is 4, z is 3. Now for this one, be careful. Here we have reciprocal x, reciprocal y, reciprocal z here, here, and here, and here. So what we do is we let u be 1 over x, v be 1 over y, and z be 1 over z, well, w be 1 over z. We'll solve for u, v, and w, but then we have to convert back by having x be 1 over u and y be 1 over v and z be 1 over w. U and x are reciprocals of each other, so are v and w, so are w and z. So appropriately converting, you get this system. 2y minus v minus 3v is -1. 2u minus v plus w is -9. U plus 2v minus 4w is 17. A 3x3 system. And after a lot of details, as before, but that's not the important detail right now, we get values for u, v, and w, respectively, -1, 5, and -2. But don't stop there. The book asks for x, y, and z. So convert back by taking reciprocals and thus get x is -1, y is 1/5, and z is -1/2. And that's the solution to this system. Okay, we're done with this. I was half tempted to move on, but no, there aren't enough of us. And this is, well, I like to say that holidays cast their shadows before and after. One moment.